Our story starts with Pong. Now, Pong wasn't the first arcade game. In fact, Pong wasn't even the first arcade game with sound. But it managed to muscle its way into the public consciousness in a way that none of its predecessors had. Before Pong came along, the domain of the video game was the university computing lab. The hardware required to run games ran to tens or hundreds of thousands of dollars, and it lay beyond the reach of even the most committed of home enthusiasts. Pong turned that idea on its head. It was the machine that domesticated video gaming. Atari's founders, Nolan Bushnell and Ted Dabney, had hired Alan Alcorn, a young engineer that they previously worked with at the electronics firm Ampex, and set him to work on developing a bat and ball game. Now, it's important to remember that this was in the days before microprocessors, and there were no standard tools or methods for developing video games. The programming language C was only just in development at Bell Labs, and it was still a couple of years away from release. With a limited budget and no well-trodden path to follow, Alcorn took a trip to a Walgreens drugstore and bought a black and white television set for $75. He developed the whole game on that set and a cheap state machine, a jumble of logic chips and diode arrays. As the game came together, the team decided to add sound. Bushnell wanted the roar of a crowd with every point scored, while Dabney wanted a boo and a hiss when you lost a point. Alcorn didn't know how to make either, and he was fast running out of parts on the board, so he poked around in the sync generator to try and find a suitable tone. By default then, rather than by design, the sound of video games had been defined. They were the sounds that were already in the machine. Following on from the success of Pong, Atari began work on a home video game console in 1975, and its Video Computer System, or VCS, launched in September 1977. Back then, memory was phenomenally expensive, tens of thousands of dollars per megabyte in fact, and so to keep costs down, the engineers devised a novel way of minimizing the machine's memory requirements by working with the mechanics of the cathode ray televisions that provided the display. Cathode ray displays build up the images by firing electrons from an electron gun at a phosphorescent screen that soaks up the electrons and glows to form the image. The electron gun slews from side to side and up and down dozens of times a second, but, and this is the crucial part, it has to stop firing as it transitions between lines to avoid overwriting parts of the display. Now, nearly every console and computer uses what's called a frame buffer, an area of RAM that stores a full image of the screen display in memory before sending it in its entirety to the display. Now, even for a relatively small monochrome display, the VCS would have needed a 1K frame buffer, and that would have pushed the cost of the device well beyond its target price point. Instead, Atari's solution was to create a graphics chip, the TIA, or Television Interface Adapter, that removed the need for a frame buffer completely by building the image directly, a line at a time, on the screen as its electron gun slewed from side to side, carrying out the game processing in the moments that the electron gun was turned off as it transitioned between vertical lines. The cost saving on video memory shifted the responsibility for the video display from hardware to the game code, a complex process that's still described in game programming folklore as racing the beam. Now, what, you might well ask, has any of this got to do with music? Well, on this chip, alongside the display mechanism, were two independent audio circuits that were also synced to the display, whose output was multiplexed and sent to the television speakers via an RF modulator. The oscillators were basic, providing just 1 bit of resolution. That is, the oscillator could be either fully off or fully on with nothing in between. But by sending the chip complex sequences of ones and zeros generated in real time using a simple computing device called a linear feedback shift register, they were capable of producing a wide range of different pitched and noise tones. The rate at which these sequences were generated was synced to the horizontal video sync counter and then sent to a 5-bit frequency divider circuit, giving just 32 possible pitches. The actual frequency of each tone depended on two factors: the frequency register and the length of the bit sequence. Longer sequences increased the period of the wave and so reduced the frequency of the tone. The trouble was that although there were in principle 32 pitch values to choose from, because of the limited resolution and the relatively low master frequency from the horizontal sync of the display, most of the TIA's pitches departed so dramatically from their true musical position that they really couldn't be used. The TIA was really intended more for sound effects than it was for musical expression. And there's an interesting parallel to draw here with the music of the late Renaissance and early Baroque. Although nowadays we tend to tune our instruments to equal temperament, meaning that each semitone interval sounds exactly the same as every other, that's really a fairly modern invention. A few hundred years ago, music would have sounded quite different. For Renaissance composers, the ideal was just intonation, a system of tuning based around the frequency ratios of the harmonic series. Now, unfortunately, thanks to a quirk of mathematics, it's not possible to build a consistent pitch system around it. And while it sounds mellifluous when used melodically within the 1, 4, and 5 chords of the root key, the moment the music starts to venture further afield, it sounds dreadful. In order to achieve a more usable range of consonants, some of the notes in the scale would be deliberately detuned or tempered, losing a degree of pitch accuracy in favour of a better intervallic balance overall. By prioritising different tuning goals, different tuning systems have very different tonal colours and textures as you move through the 24 major and minor keys, a feature that was showcased by Bach in his famous 48 preludes and fugues. Now, crucially, the composers of the time understood that, and they worked to the strengths of the tuning systems that they used. And interestingly, a similar process happened on the Atari as the hardware limitations of the system began to directly influence the aesthetics of its music. During a presentation at the Game Developer Conference in 2011, the founder of Activision, David Crane, explained that Gary Kitchen, the developer of Pressure Cooker, calculated the 9 notes that could be reasonably approximated by the VCS and marked them out on a Casio keyboard. They hired a professional jingle composer to come in and write a melody for the game using just those marked notes. That soundtrack, simple as it was, really marks the beginning of the professionalization of video game music and the role of the game composer. Before then, it was just one of the tasks alongside gameplay and graphical design and programming that was carried out by an individual. When Activision hired a professional to write the tune for Pressure Cooker, they were acknowledging music as a core component of the video game experience and a specialist task that needed specialist expertise. That the composer was so constrained speaks volumes about the creative and technical ingenuity of those early development teams. Any form of media music, whether it's the underscore of a movie, the title theme of a TV sitcom, or a radio sting, is shaped by the medium that it's written for. But those early gaming platforms really accentuated that fact. On the VCS, the meagre memory and the very limited capabilities of the sound chip really constrained what musicians could do. That they managed to create anything that even vaguely approached music is really quite remarkable. Now we're going to move to a discussion group. What I'd like you to do is spend a little time investigating the launch of the Atari. What sort of gaming context was the console released into? What were its main competitors? Perhaps most importantly of all, why do you think that the Atari succeeded when other consoles offered better graphics, better sound, and better gameplay? Please post your thoughts and spend a little time reading through the thoughts of others. What are the main themes that emerge? Can you see any parallels with other consumer devices, video recorders perhaps, or later generations of consoles and computers?